This paper reports the effectiveness of various methods of inhibiting spoilage of Roma tomatoes. Tomatoes were soaked in water, salt water, bleach, vinegar, or vegetable oil, and were then dried or left undried. The authors observed the tomatoes for 14 days and recorded signs of spoilage. They found that the undried saltwater group remained the process compared to the control, and concluded that saltwater exposure is a simple and effective method of preserving tomatoes. Why did you decide to work on this specific project?
Last year in our biology class, basically everyone does an independent research project, and so basically I did some brainstorming, and the area I wanted to focus on was how different preparation methods, different solutions and preservatives affect bacterial counts on produce.
I focused on how different environmental conditions could affect food spoilage. So we sort of combined our ideas into one idea, and there was our title, the effect of various preparation methods on the spoilage of Roma tomatoes.
Another thing is, as we kind of started developing what we wanted to work on, we decided to test two variables, not just one, to kind of get a more complete picture. So we did, these different solutions, different preparation methods, but also, whether to dry or leave the tomatoes undried after you soak them. And we thought that would yield the most, accurate and useful results.
What did you learn from this project, and did you find anything particularly surprising or challenging?
Yeah, so we learned a lot from this project about, the scientific process in general. We learned a lot about, I didn't know what water activity was before this. I learned about that and how it explained why the saltwater preparation was the most effective. And we learned a lot as well about the relationship between mold and bacteria. We never really thought about there being competition between them, but some of our results suggest that, so yeah.
One of our major challenges was coming up with the spoilage scale itself, because there's no scale out there that you can just go and get that tells you, the various stages of spoilage in a tomato, attributing them to a number or assigning them to a number. So we had to create our own spoilage scale. We called it semi-quantitative because we used 4 different categories. It was mold growth, discoloration, damage to skin, and then wrinkles. And we scaled each category from 1 being the best to 5 being the most spoiled. Another big challenge was at the grocery store. As you can imagine, the tomatoes in the batch given to you by the grocery store could be from different batches sent at different times, maybe even on different days to the store. So controlling that variation across tomato batches was also another challenge. Luckily, for the second iteration, we were given a full box of tomatoes, so we knew that was from one batch.
How do you think these treatments would carry over to other types of produce, say oranges, potatoes, or strawberries?
So for oranges, we think that, oranges have a very different protective layer compared to tomatoes. So we're not quite sure that the results would carry over to oranges, just because they have that extremely protective outer skin. For potatoes, they could carry over for sure. Salt water, some of the solutions we use, bleach, salt water, vinegar, those are pretty effective in eliminating pathogens. So those could certainly work on potatoes, which are, their skin isn't as thick as oranges, for example. It's closer to tomatoes. In terms of strawberries, that's tricky because, they're much smaller than the tomatoes that we used in our experiment. It would be tough to, judge the spoilage process on individual strawberries. But like I said before, these solutions are known to eliminate pathogens, so it could certainly work on strawberries as well.
If you were a farmer or a market, how would your results impact how you decided to preserve and market your produce? Keep in mind that food distributors want to preserve large amounts of produce affordably, and the produce sometimes needs to be transported over long distances.
Yeah, so when we went about our study, we kind of focused on the consumer side of things, after people have bought tomatoes, how to keep them good for a longer period of time. So we didn't fully consider, whether farmers or distributors could use these techniques, but they certainly could. Non-organic farmers already apply certain chemical preservatives to their produce. So they already have those methods available to them. But we certainly think in the future one thing we'd like to do is compare those commercial preservatives to these techniques that we used here.
Yeah, and our findings were definitely really important for this application because the saltwater solution was really effective in inhibiting spoilage, and it allowed the tomatoes to be preserved for weeks, so distributors could really find this useful.
If you were to run these experiments, are there any aspects you would like to change or elaborate on?
Yeah, so there are definitely a few things that we'd probably change in the future if we were to repeat the experiment. One would be to take the bacterial counts before and after we started, applying these different preservatives to the tomatoes. In our second iteration of the experiment, we only took the bacterial counts at the very end and then compared. If we were to take them before as well, then you could compare the net change, and it would be probably more effective than just comparing the final counts.
What advice would you give to other students interested in starting a science project?
So it's really important that you're genuinely interested in what you want to do in the science project that you want to carry out. We sort of combined both of our ideas that we were both really interested in, and only then will you have really the dedication to see it all the way through and take it one step further than most people do.
Yeah, like for example, one of the things that I just really liked about this topic was how just directly applicable it is to everyday life and to pretty much everyone. It's just a simple way of helping people, and that's why I was really interested in what we did. So if you're looking to conduct a scientific experiment, you should have that. Another thing that we would certainly recommend is planning ahead of time. That's something that we even could have probably done a little better job of. For example, as I mentioned before, the bacterial counts. So just stuff like that, like really developing a complete picture of what you want to do. That's gonna make things a lot easier.
Do you guys have anything you want to add?
Yeah, one thing that we both learned was that something as simple as saltwater, it's not always the complicated ideas. The simple ideas can really be effective, and saltwater was really effective in inhibiting spoilage. So we see saltwater as a really good way of people around the world stopping, produce spoilage, and we'd love to carry out further experiments in the future to see how it affects different types of produce. But the main idea of this is that saltwater is so easily accessible to so many people around the world, and it'd be a great way to stop spoilage.